Algebra 2010, question 4. The graph opposite shows the average flow, y vehicles per minute, against time, t hours since midnight, for values of t between 0 and 14. Use this graph to, part 1, find the average flow when t equals 5. Okay, so that should be pretty straightforward. We'll just go down to the graph here, look for where t equals 5. So that's going to be there. And then we just go up from that point to the graph, a nice straight line, and then go across. And we can see there that that is going to be, well, I think it's probably about 13, because here this point is going to be 10. So it's halfway between 0 and 20. So then it must go up in 2s. So 10, 12, 14, 16, 18, 20. So therefore this point is going to be 13. So I reckon the answer to part 1 is 13. So that's pretty straightforward. Then it says find a gradient of the graph when t equals 10. Okay, so we're going to t equals 10, that's here. Go up to the graph, to this point here. Now we need to find a gradient of the graph at that point, which means we need to draw in what's called a tangent, which is a line which just brushes past the point and is the same steepness of the graph at that point. So you get your ruler out. If this is my ruler here, you kind of line it up so that it goes through the point, and also it needs to be the right steepness of the graph at that point. So I need to kind of make sure it represents the graph. Make it quite long as well, because then it's easier to work out the gradient. Okay, there we go. Right, so now all I need to do is work out the gradient of that line, which I'll do by drawing a little triangle in here. Doesn't matter where you draw your triangle, just maybe try and find a convenient place. Something like that, perhaps. And then we just need to work out how far across and how far down it goes. So let's do the up and down first. This point here at the bottom is at 60 on the y-axis, and this point here at the top is, right, well, there's 100, so it goes up in 2s, remember, 102, 4, 6, 8, 10, 12. And 112 minus 60 works out as 52. Okay, so then we just need to go work out how far across it is. So this end, if we go down to the bottom, is at this point here, which we need to work out what that is. So it's quite hard here maybe working out what this goes up in, but I reckon it probably goes up in 0.4s, and let's just check that. So 12 is here. If it goes up in 0.4s, that makes it 12.4, 12.8, 13.2, 13.6, and then 14. So that must make this point here 12.8. So 12.8. Now we need to work out what this one is. So just go down to the bottom there. That's easier, because that's just slap bang on 8. But that means that's 4.8 across. Okay, so the gradient is the rise over the run. Because it's going downwards instead of upwards, that means it's minus 52 divided by the run, which is the 4.8. Okay, so just use a calculator to work out what that is. So 52 divided by 4.8 equals, press this button to work out what it is in decimal, and it's about 10.8. But it's minus. Okay, so that's part A of the question done. Right, part B. The average flow, y vehicles per minute, can be modelled by the equation y equals 55 plus 45 cos of 180 over 7 brackets t minus 17 degrees for values of t between 14 and 24. Complete the table of values opposite. Okay, so table of values question is always easy. We just go to table function on the calculator. So that's mode table. Type in the f of x. Okay, so that's all this stuff here. Type it exactly as you see it. 55 plus 45 cos of 180 divided by 7. Okay, now you might want to use maybe the fraction button for that, because to make it look exactly like how it's written in the equation. So 180 over 7 may be better. and open brackets, and we can't use t, it's x in the calculator, so alpha close brackets get x, minus 17, close brackets, and then another close brackets. Press equals, start. Okay, well, we want to start here at 14, end. Okay, well, I guess we're going to end here at 24. Now, I know we already know those two values, but this would be a good way for me to check to make sure I've got it right. Step, okay, up in twos. And there we go. Okay, so there's a table. Now, because I put 14 in, I can check to make sure this is right. It's getting 14 and then 65, so this must be correct. So I just fill in the other values. They've done these ones to just to the nearest whole number, so I'll do mine to the nearest whole number as well. So it looks like 16 here is 95. It's 95.5, so I'll round that to 96. Okay, 18, it's the same again, 96. And then go down to 20 and 22. So 20, 65, and 22, 27. And just double check that 24 is correct. 24, 10. Okay, so that's all good. Okay, so we've got our table of values filled in, and now it's going to ask us to draw the graph. So if we just fill those values in from the table again, 96, 96, 65, 27. So 96, 96, 65, 27. And we've got to plot those values on the graph. Okay, well, I've done that already to sort of speed things up. So these are all the points here plotted. Then it says we've got to draw the graph, which means more than just plot the points. We need to kind of join them up as well. So what we want to do is kind of get a nice smooth curve. And I suppose ideally I'd probably quite like it to kind of match up with what's on the left-hand side. So let's see if we can have a go at that. Now it's got to make sure you draw it through all the points. And try not to make it kind of wiggly. I know I've managed to make it a little bit wiggly just here, but that's because I'm drawing it on a smartboard. When you're drawing it on pencil, you're going to make that look much better. But make sure, remember, it goes through all the points that you've plotted, and it's got to be accurate to within half a square. Okay, next part of this question. What is the maximum average flow predicted by this model? Okay, so the model is the bit that I drew. Because that was the bit for between 14 and 24. And what's the maximum predicted by it? Well, my graph kind of looks as if this point here is the maximum. Let's mark that maybe in red. Looks like this point here is the maximum. I'm guessing this is kind of supposed to be symmetrical with this point here. So, yeah, I think probably I ought to maybe redraw that slightly, perhaps, so it goes exactly up to that point, the same point as this one does. So that means that it's going to be the maximum value is 100. So it's 100 there. So let's fill that in. Maximum flow predicted is 100. When is it predicted to occur? Okay, well, that means just kind of go down. And it looks like it's going to be exactly between 16 and 17. So halfway between is 17. Okay, why is the model y equals 55 plus 45 cos of 180 over 17 minus 17 not suitable for all values of t in the range between 0 and 24? Okay, well, let's have a little look back at the graph again. Now, obviously, it fits quite well for values between 14 and 24, but they're saying, why does it not fit for values between 0 and 24? So, in other words, why is it no good for values less than 14? Okay, well, let's try and think about what would happen to this model. It's a trig graph, so that means they sort of go up and down like this. Okay, so if this one's going sort of like this, then for values below 14, it's going to kind of go down here somewhere, and then it's going to kind of come back up again, but it's certainly not going to go like this, which is what we want it to. So something like that, perhaps, for values of t. So let's say for values of t less than 14, the graph of the model does not fit. And then perhaps you could give an example of a point where it doesn't fit, e.g. t equals 0, perhaps is the easiest point. If you've got t equals 0, according to the model, y is going to equal 55 plus 45 cos of 180 over 7 times by 0 minus 17. And if we use the calculator to calculate what that is, let's bring the calculator back. So if we use a calculator to calculate this, 55 plus 45 cos of 180 divided by 7 times by minus 17. Work out what that equals. That's telling me that's 65. Okay, so that's equal to 65. Except I didn't really want it to be 65 because it's supposed to be 10. Okay, because it's 0, it's meant to be 10. So clearly it doesn't fit for values below 14. And that's it, job done.